Hi, everybody. Welcome. We're going to get started.
Yeah.
Go for it.
Awesome. And thank you for coming. And hello, folks online. Let me hit the play button. I hope you're able to see the screen now. All right. Where are the speaker notes? Oh, never mind. We have no speaker notes. All right. Reading the spec. ECMAScript. With me, Hemanth, Gnumanth on Twitter, and
I'm Jordan.
This is me, Hemanth. I'm an engineering manager at PayPal. I'm a TC39 delegate and a Google developer expert for web and payment domains. And we are hiring full stack JavaScript developers. Don't hesitate to reach me at Gnumanth on Twitter and everywhere else.
Hi, I'm Jordan. I work at Coinbase. I'm building an open source office for them. I was the editor of the JavaScript spec for 3 years, and I'm on the board of the OpenJS Foundation. I maintain a bunch of open source projects. So reach out to me if you have any questions.
Yeah, before we get started, we would just like to share our stories on how we got into specifications. I let Jordan start first.
Sure. So back in 2012, 2013, I found myself maintaining the ES5 shim and ES6 shim, which are libraries that allow you to polyfill at the time, new JavaScript behavior in older browsers. So for example, if in Internet Explorer you wanted to .map on an array, you would use the ES5 shim to do that. And one of the TC39 delegates reached out to me on Twitter and invited me to attend a meeting. I showed up, and in the first meeting, I was able to meaningfully contribute to the standard, and I was just hooked on that feeling. So I've never left. So I've been involved since 2014, and I've gotten more and more involved in JavaScript itself, and I've started to branch out a little bit into some web standards in Node.js, and I'm in the standards working group for the OpenJS Foundation and a few other things like that.
Yeah, I started off reading specifications in my college days when Java was the thing and people were getting the Sun certified Java programmers certificates, and I was curious and I got to get into the specification and started reading and seeing examples there. And then when I switched over to Node, I started contributing with a lot of ideas, and of course Jordan was there and was brainstorming on IRC and things, and later on I joined with TC39 committee, and it's been 3 years now, and I've been contributing with authoring few specs and co-championing few, and it's been an awesome journey. So before we get started, we want to talk about some algorithmic conventions. So as we know, spec is a set of text, and it can't be like a program, but still it should have some kind of a grammar or a syntax that would make us easy to understand and what it is saying. And yet it should not be too much of an esoteric science, right? So it should be convenient and precise, and once you read the spec and get used to it, you should know exactly what the spec is saying. So for that, this is a section in the spec itself, but let's try to summarize some part of the algorithm conventions here. Abstract operations. So you would have probably used a lot of abstract functions, and you'd probably invoke a function as you see on your left with the operation name and passing arguments to it. And if it's an optional, it will be in square brackets, probably you would have seen them on MD and docs and likes. And you would do some value dot operation name with args passing to it. And this is just like the abstract operations, and these kind of lines you would see in the spec. There's also syntax directed operations. We will not dive too much into it, but just think of it like a set of statements which says, hey, what happens if I call an abstract operation? What is the value that I get, and what do we do with it? Right?
And so in a normal programming language, when you call a function, it usually either returns a value or throws an exception, something to that effect. And in a regular language, right, most of them have a mechanism to propagate those exceptions. So if you are 8 levels deep in a function and an exception is thrown, it just kind of bubbles all the way up. It's obviously not universal, but that's the way most of them do it. And but in the specification, there's no engine to bubble up exceptions. So we have to have these explicit steps to be able to handle those exceptions and bubble them up the stack. And the way that that's done is that abstract operations that can throw an exception, they do this by returning a completion record, which is just kind of a container to encapsulate how the operation finished.
So set of operations would be like this, as Jordan was just mentioned. We have like a top level step and we have substeps. So if you go to a spec and probably read a particular function definition and see how it behaves, this is how it would be defined. And there is an assertion statement that happens, which is not really part of that program, but we assert to make sure that this behavior is accurate. And if not, the spec is not implemented properly. Say you have an environment where the assertion is not working or it fails to behave, then it means the implementation is wrong. And we have the runtime semantics up next, where we have the completion record that we just mentioned. And if you see this statement in a spec which says completion record, what does that mean? That means there's an assert statement which says completion record is a type of completion record, and what gets returned is a completion record, right? So what is a completion record in a specification, right? So in a runtime, how do we define a completion record, right? What does it consist of?
Yeah, so I mean, these are what we call kind of spec fiction. It's not a thing that necessarily exists in any engine. It's just the way that the specification describes the way it's supposed to work in a precise manner, so that however the implementations decide to do it, they can do the correct thing. So in this case, the spec has this record type, and it has these internal slots, and for a completion record, one of them is type. And so the most common are normal or throw, which do the things you might expect. There's also, return and break and continue, which are relatively rare, and you can probably guess what those do, so we won't dive into them.
Yeah. So it talks about the flow control and what happens when there is an exception, things like that.
Right.
So what happens if we throw an exception, right? Then you can see this in an algorithm step where you say, throw a type error exception. It's obvious what that line is doing, but what it means internally is return a throw completion and a newly created type error object. That's what it implies. So whenever you see a line which says throw a type error exception, this is what it implies. It's returning a throw completion record. And throw completion record refers to any completion record with the type value to be thrown.
And I wanted to comment here as well. As you may notice, there's no error message described here. There's a number of reasons why the spec does not include anything about specific error messages. One is because individual browsers and engines want the freedom to be able to word it better over time, and if the spec locks it down, they can never make it any better. The other reason is because multiple languages exist, and if the spec described it in English, what happens when we want to translate it into a new language? Either we have to specify a translated form for every language that we want to use, which is a little untenable, or we have to leave it up to the implementation. So even though engines try to agree and they try to do the most helpful thing, it's kind of intentionally implementation defined.
Yeah, and anyone can go ahead and pick up the spec and implement, right? It need not be just the browsers or the node environment. So it's left to any one who wants to implement it. So return if abrupt. If you see a statement which says return if abrupt with arguments, what does it mean? Again, it means if an argument is an abrupt completion record, it returns a completion record with type of arguments. Else, if the argument is a completion record, then it will take the value from the internal slot and set it. Right? It's basically like unboxing and taking the value out. And if it's equal to say that return if abrupt and pass in an abstract operation with it, right? And it's a similar thing like how we did for arguments. So it basically boils down to these three steps. Instead of writing these three steps everywhere, we just say return if abrupt complete with arguments, right?
And this works the way you might be familiar with await working a little bit, in the sense that when you await a value, you either get a thing out or you get an exception, and that's essentially what this is doing.
Yeah. So the similar thing, it's an abrupt completion reference if it's of a completion record of type being a value being normal. That's like a normal completion record. If not, it's an abrupt thing, right? And there are shorthands for it. And instead of writing all those three steps everywhere, wherever your function is doing a particular step, instead of saying all those three steps, you can use shorthands where you could say question mark operator name, or you could have a bang on an operator name. The question mark operator name is equivalent to saying return if completed, return if abrupt, and the operation name. Or it could, what does question mark and exclamation mean? Question mark means, hey, this might throw this, right. Or exclamation is, it should never throw, and if it throws, then it's an implementation bug.
Well, and specifically, so it means that this operation can sometimes throw, but in this code path, it can never throw. I would say that this is one of the parts that trips people up the most when they get to the spec, because they see just question marks and exclamation points littered everywhere, and there's no real description to tell you what it is unless you've read the algorithm conventions section.
Yeah.
But I'm familiar with the spec from before we introduced the shorthands, and this is a vast improvement. It was like 30 or 40% longer, and it was just a lot harder to read. So it's unfortunately just one of those things you have to learn. Yeah. The other thing is, if you have ever looked at any of the specifications before the ES22 version, the way that abstract operations worked around completion records was very different. They all magically returned 1, and they all, when you tried to access a completion record, it like magically unboxed it for you. It was a lot of implicitness, and so we've kind of reformed all of that. And so now the only things that return completion records are things that can sometimes throw. And if it can never throw under any circumstances, it just returns the value directly, and we don't have to deal with the completion record. So it's a lot easier to get your head around it, I think, now than it used to be.
Yeah, just imagine all this, writing all these 3 steps every time, probably recursively if your function is doing that, and rather you replace all of them with one shorthand, how precise it becomes. And that's why reading the algorithm conventions is a very important part of the spec. And implicit and normal completions, as we mentioned, we can just probably skip over this. It's just the type of a normal completion. This is where you get the value. And we have mathematical operations. I remember this pretty evidently in one of the ES5 shims. I had sent a PR. This was 2009, 2010-ish, and the PR had already got merged, and then Jordan came in and said, hey, no, it looks like you've missed a -0 there. I was like, what is -0? Where is this coming from? And that's when I started pestering Jordan more to get into the details of mathematical operations. How do they work in the spec?
And yeah, as you can imagine, there's JavaScript numbers, and then there's like actual math. And as you may have experienced, those two are not the same. And the spec needs to be very careful about which type of number it's talking about. Otherwise, it's going to have like computational errors when it tries to do math with numbers. So, we have mathematical values, and then because it happens a lot, we have the extended math values, just normal numbers plus infinities. And then number types, and then big ints were added a few years ago, and that's of course another type. And the
mathematical notations, right? You want to talk about the mathematical notations? Like, so suppose you see this kind of an F bar is what Jordan kind of names it, and I'm not sure if he mentioned that he was already an editor for the ECMAScript specification for many years, and F bar is the term we call it. So if you were to represent the number value of X, then the spec would use an F bar of X. And if you want to represent the big value of this particular value X, we would say a Z bar of X. And similarly, we have other notations for the mathematical value of X. You would do an R bar of X. And the plus F and the minus F, the mathematical values of 0, is how the spec represents.
And before this stuff was cleaned up, there was a lot of like sort of math errors in the spec that engines mostly got right by chance, but like it was incoherent if you just kind of read the document and paid attention to it. So we're like lucky in that a lot of browsers kind of just figured out what the right thing was and did that. But now this stuff has been kind of cleaned up a lot and made more explicit, and so it's a lot harder to mess it up just by reading the spec if you're trying to make a new engine or add something to a browser or whatever.
Yep. So I think, what time is it? It's time for a demo. So let's head to a demo. All right. So on the right, for your right, you would probably see an array.prototype.map. How many of you have used map before? Obviously, all of us, right? So say we have a set of numbers, and we want to say an array of numbers which are strings, and you want the integer value of it. You would just map and pass it to parseInt, and you would get the equivalent array, right? So let's see how you could read the specification, and we'll try to map that to a code sample to understand how the code works, the way it works, why it works, and how you can map it to specification. So if you open up the ECMAScript specification and come to this particular section where array.prototype map is, here's the definition. So whatever we spoke in the slide so far should make us easy to understand what this is doing. So let's start. Say we have let O be the object, and we do a question mark, and I hope you remember what question mark means, and we do a toObject on this value to get that value. So what does toObject do? It will try to create an object of that particular value, and if it's not possible to create, it would throw. So let's see this particular example here. Is it okay on the screen? Okay, right. So what I'm trying to do here is I'm doing array.prototype.map.called undefined, and what happens here? The two object gets invoked with that value that's undefined here, and what is the error we see? We see that array.prototype.map called with null or undefined. So that's why it's not able to create that particular map over that particular value, and it throws, and that's where we caught it, and we see the message. And similar for null.
And this is the same error you might be used to experience, same type of error you might be used to experiencing if you try to access a property off of null or undefined. So those are the two values that can't coerce to an object.
Yeah, that's because they're doing a two object internally there too.
Right.
Yeah. Then say we want to calculate the length, then we take and assign the value of length to length of array like. What does array like mean? So even though we've been used to the notation of creating an array, internally it's represented as an object where the values are the keys are strings, and the values are the values that are within the array. And those are array like. Array like in the sense if an object has a length, it can be like considered as array like. So let's see an example on how this maps, right? So we have an object here with 0, 1, 2, 3 and certain values, and the length is 2. And then what we go ahead and do is we go ahead and call array.prototype.map on the object. What we get back is a value index array. We are multiplying it by 10. What do we think the result would be? We have an object with properties, and we have a length properties whose value is 2. We mapped over that object and multiplied each of the value by 10. Let alone the result. What do you think the size of the array would be after this operation? Would it be equal to the length, or equal to the all the attributes that are there in the object? Right? What it would. So let's see what that would be. I'll try and see the index here. So if you see the value would be 2 rather than having all the values here. Why is that? So what we did here is we did length of the array like, and after we got the object, we did the length of the array like. That's where we get 2, and then even though we mapped through the entire object, because the length was 2, the value we get is 2, and not everything in the object is mapped over. And if you look at the other example where length is not there, right? If we go ahead and execute this, what we would get is an empty array. Because if you look here, we have an object.define property on the object with the length attributes, and the set function is not setting any value to it. It's empty. So the value would be an empty array. So let's probably put this in the console quickly to see how it behaves. Right? So if I take the first example here, I take this and I console log the result. Maybe I have a filter. Where did that? Right. Let me take the console here maybe. Rather than the specification. Maybe the code sandbox is overriding the console.
Wouldn't be a demo if it worked perfectly.
Yeah. Right. Maybe in the console I've changed the levels to not to show me the logs. Custom, yeah, default, there we go. Yeah, now we see it, right? So let me bump up the fonts a bit. So if you see here, even though we had 13, 11, and 7, what we got was 130 and 110 with length as 2 because we had specified the length there. The other one we were talking about is having an object.define property, object with length whose setter doesn't set the length at all. When we go ahead and run it, we get an empty array and its length is 0, right? And finally, we have an empty object again where the length is not defined at all. Rather than having a property defined whose setter is empty, we have a regular object without the length, we get back the empty array again. So let's go back to the spec and see where we are. So we got the object, we did 2 objects on that, then we got the length of that object that using length of array like abstract operation, and then we are checking is callable callback. It's very simple, right? Is callable callback, if it's false, then it throws an exception. That means it's not a callable, right? So if you look at this example here, where we have an array of true, 5, an empty array and null, these are not callable, right? You can't, it's not a function. You can't call them. So what happens if you try to map over them? It basically goes to step number 3, where it says do an is callable check, and if it's an error, go ahead and throw an error, right? So let's see how that behaves. So we did see that type error. We see all the type errors. That's what the spec says. So it says type error true is not a function, and then it says type error 5 is not a function, type error empty array is not a function, type error null is not a function. That's where it throws, and that's what this code is trying to demonstrate. And then we go to the next step.
Yeah, so the next step here is saying array species create. I'll talk about species for a minute, but essentially, if you can look at this code, you see the first one is class myArray extends array. What the examples are demonstrating is that if you make a new myArray and you .map it, you'll get a new myArray, which is what you would expect when subclassing. However, if you want to get something different for reasons, then the way to do that is this symbol species protocol. So basically you return a different kind of constructor. So the mySpec array, if you map it, you'll actually get a different kind of thing out of it. The sort of rationale here was that then you don't have to override the .map method. You can just hook into it in this way. It's something that came, I think, primarily from Smalltalk, but it's not a facility that pretty much anybody uses, and it's actually caused a lot of security bugs on the web. So browsers are pushing really hard to try and get rid of species from the spec, so please don't use it. But the short answer of what this step does is it just makes an array of the expected length. So this is where the new array that .map returns is first created.
So let's see the quick example of that. As you know, like we created 2 instances of array, my array and my spec array, and then we are checking if it's an instance of that. So A1 is my array and A2 is my spec array. When we do A1.map and we check if it's an instance of my array, yes it is, it's true. Then A2 is my spec array, and we do a map and check if it's an instance of my spec array, and we expect it to be, but it's not, because we have a static method here on a symbol species, and we are saying return my array instead of my spec array. So that instance now it belongs to my array instead of my spec array. And I was just like joking the other day that what is the most endangered species in the specification? Maybe symbol species.
Wow. There you go.
All right. So we have, where are we now? So now we did do array species.create, and we are calling it A, and then let k be 0, as simple as that. We have an index which is set to 0. And on step number 6 is where we iterate, starting from k till the k is less than length. We keep incrementing k by 1 on 6.d, and we repeat. And what happens internally? So we go ahead and do a toString of f bar k, and we know what a bang means now, that this will not throw, and if it throws, it's a spec error, implementation error. And then we call it as pk, and then we check if k is present with has-on property. Why are we doing the has-on property check?
Yeah, so there's something in JavaScript that a lot of us wish didn't exist called sparse arrays. Essentially, as you can see in the example that Hemanth is about to put up, a sparse array is when there's a hole. In other words, it's an array of, in this case, length 3, but the index 1, the second item, isn't actually there. It's not an owned property on the array, and you can test that with the in operator. If you just try to access it, you'll get undefined as long as nobody's messed with array.prototype. But the .map method was added in ES5 in like 2009, and all of those methods did, the way I would describe it is they preserve holes. So it's doing this has property check in the spec, because if it's a hole, it just skips over it entirely, and it leaves a hole behind. Like the new array was already created at the expected length, so there's just a hole there, right? It's entirely an array full of holes, and so the end result is you have another sparse array. I assume this was motivated sort of by performance. If you have a sparse array of length 1,000,000 that only has 3 things in it, you don't want to call your callback 1,000,000 times. You only call it 3 times. But it turns out that sparse arrays are very slow, and they're very messy to think about, and they leave you exposed to people putting stuff on array.prototype, which does sometimes happen. So all of the array methods added in ES6 in 2015 and later do not preserve holes. They ignore them. They just pretend that that's not a thing. And so if you .flat or something, or flat map an array with holes, you will get an array without holes. But since .map is one of these ES5 methods, it preserves them. And so the has property check is checking that.
Yeah, and if you see the sparse array on the console, it says 1 empty 3. That empty is the hole that we are speaking here. But if you look at the representation, on 0 we have 1. On 2 we have 3. But where did the 1 go? Right, the index 1. But then it says length is 3 because there's a hole there. But when we call our map, it does this has property check and then makes sure that it doesn't operate on the hole.
And the representation in the console will vary across engines and browsers. So Chrome here uses empty to display them, but not all of the browsers do it the same way. It's changed over time, so,
Yeah. So here's a quick example on the same where we have count 0 and we have a count calls to just make sure that the for each here is called on this every time. And when we do a count here, we go ahead and log, what we get is 2 instead of going through the entire array length, and thereby it's performant and we need not worry about the holes. And that's where we have the has property check. And now we have done the check, we got the key present. If it is true, that means the key is present in that particular object. Then we'll go inside and get the k value from get property that's doing going to the object and using this property key and getting that key value. And then we have the map value. This is where the crux of the entire map falls into. So if you look into the signature here, what do we have? We have a callback, we have a this arg, we have a k value, we have an f bar k, and we have the object. So that's equivalent to how you write a map, right? You would just do an array.map, and then you pass in a callback to it. And what do you have in that callback? You have a value, you have an index, and you have the array itself, the array from which you're calling map. And that if you map it to the spec here, that's on 6C substep 2, you see that there's a callback function. That's the callback function we have. Then we don't really see the this arg here, right? So what do we see? We see the value, the index in the array. Where does the this arg come in the map signature? If you have read the docs or used this before, this is where the this arg comes into the signature, right? So what does the this arg mean and how does that operates? So let's see a quick example.
And just real quick, the generic term for the this value
execution
that isn't hard to say is the receiver.
Yeah. So we can also call it as the execution context or
yeah, I've tried to avoid terms like that because terms like context or scope or something, they sort of imply capabilities that aren't there. But the word receiver is, I think, pretty precise. It describes the object that's kind of receiving the method call. This is also sort of a small talk idiom, but I think it's actually the right term.
Right. So Jordan is referring to a selfless JavaScript, maybe, right? Where if you remember those days where you're doing like this equals self and that equals this kind of a thing. So it's more like a selfless JavaScript with all the arrow functions, maybe. And so here's a quick example again. We have array.map on, and we are. If you look into this example here before going to the console, this is more readable, I guess. So we have an array.map and we have the function here. We are not using the arrow function here because the execution context is bound already or the receiver is already bound in that. So that's why you have to use a function here. This is a classic example where you can't really use an arrow function. And we are passing 2, 4 here. If you notice, we are doing an empty array.map, but we are passing 2, 4 here. That would be this that gets bound here and referred as whenever you are this.length, you're basically referring to 2, 4. So what would happen here is if we go here and log it, the context is already declared. So we go ahead and give a value to it, say 1, 2, 3. So what we got back was 2, 2, 2. That is basically the length of this rather than this particular array. So rather this array had these many values, but all we got was 2, 2, 2. That is the length of 2, 4. That is this arg that we passed in. So that's where call gets invoked with the callback function, this arg key value, that's the step. And last, the important step what we have here is create data property or throw. Why do we have to create a data property or throw? What is that?
Yeah, so if we're just talking about a regular array, so first of all, a data property. There's two kinds of properties in JavaScript. There's data properties and accessor properties. An accessor property is something that's a getter or a setter, and everything else is a data property. So this is making a nice normal data property. On a regular array, that'll never fail, especially a newly created one that no one's ever like monkeyed with. However, the species stuff and subclass stuff I was talking about earlier, if somebody, it is entirely possible that somebody could make a subclass that's dumb or useless or weird, and it locks down one of these properties. And so there's a chance that this could throw if you're not doing a regular array map. And even though almost every use case won't run into this problem, the spec has to account for it. And so that's what the question mark's here for.
Yeah. So that means they can do an object.freeze on a particular property, and when you try to modify it.
Yeah, or you can define it to be non-configurable, exactly.
Yeah, so, okay. And step 6D, we already covered, that's where we are incrementing, and this while loop keeps on repeating, and finally what we have is returning the array, and that's what we get. And that's how map works. You know, it was, it's not like reading a comic, it kind of is brain consuming at times, but once you get used to it, it feels very natural, and if we have got time, we can probably.
Well, I wanted to talk a little bit about the history of this argument. It's a pattern as well that's sort of now mildly regretted. At the time, there was a lot of concern about the need, like ES5 included .bind, so the ability to bind a function and pass a receiver in and not have to use the var self equals this kind of pattern. But there was concern, I think, about binding a bunch of new functions every time you needed to map and so on. And so the thought was, oh, this will be more performant because you can reuse the function multiple times and just pass a different receiver. But in practice, it turns out that nobody uses this feature really anyway. And people like arrow functions as of ES6. And also, bind has been really optimized. So it's pretty cheap to make a bunch of functions. Even if this was an issue. So this is sort of, unlike species, which people, we're all trying to remove, this is something that we're just kind of stuck with, and all the new array methods have to use, even though, like for consistency, even though there's like not a lot of value from it, but there's also not enough harm that it's worth trying to rip it out.
Right. So yeah. I was just showing another case where you can't really use an arrow function in this case, and that's where you're using a function. And
right.
and we remember days where we used to do a console log.bind console, where we have to make sure that console is bound, and now like most of the browsers already bind it because it's not a costly operation anymore.
Right.
Yeah. Exactly. Cool. Yeah. So that was fun, and we would be happy to go through the spec on run a quick session on whatever you want to look into, like a particular function or something that interests you.
I think maybe before we dive into audience suggestions for something to go through, are there any questions that any of you have?
Yeah.
Anything we can answer? And if not, we can take suggestions or pick something.
And how are we on the time?
So when new features are like proposed or like ideas are had, do you guys write the spec first and then have somebody build code for it? Or what's kind of like the process for like building a new function? Like I saw there was some announcements today about the new ES version that had some new, I forgot what it was exactly.
Yeah.
But we was going through some of the new things that were there. What's like the development process?
Yeah, so there's a whole staging process for how things move towards being in the standard, and that's like a talk in and of itself. But and the video this morning at the keynote covered the stages a little bit. So essentially, stage 0 is like I have a crazy idea. Stage 1 is like maybe that's not so crazy. Like let's look into it some more. Stage 2 is like we are committing. We want to solve this problem, and we're pretty sure we know what that looks like. And then in order to get to stage 3, you have to have like a complete set of spec text. Everyone has to be kind of agreeing. So TC39 operates on consensus, which means that if anybody objects, nothing happens. So it doesn't mean everyone's like stoked about everything, but nobody can object. So in order to get to stage 3, you have to have this sort of complete solution that everyone's ready to start shipping. And then within stage 3, it gets shipped. If there's a web compatibility risk, it'll get shipped in browsers, and that's an important thing because we need to see if it breaks websites. But in general, we just kind of need to test it out and make sure it actually can be implemented. It can be performant. There's no like bugs that that are discovered through the process of implementing it. And then by the time it's ready for stage 4, that's when it's already shipped. It usually is on the web. We can never take it back anyway. We're confident it's finished, and then it gets landed in the specification. Yeah. And then every year, ECMA, or the standards body that the spec is in, takes like a snapshot of the living standard, and that's the yearly edition. So the ES 2022 will hopefully be approved later this month. It was, a snapshot was cut back in June or January, and March anyway. And so there's a bit of that, but there's already stuff in the specification, which is on GitHub, that isn't in ES22, that will be in ES 2023. So the yearly snapshots are nice to kind of get a sense of history, but it's really a living standard, so you'll want to go look at the latest version.
Yeah, just to add on to that, here's a quick example from one of the proposals that I was lucky enough to work on. So we normally kind of create a path to stage 4. Jordan helps most of the folks to kind of polish this. He is on almost all of the proposals helping folks, and this is how it basically looks, right? This is the path we talk to stage 4. So we say if it's on stage 4, then it needs a committee approval, then it should be implemented in 2 browsers. Like here, it's implemented on these browsers already, and then it should pass all the ECMA 262 tests. That's where all the tests are for the implementations, and you kind of merge and write the test and all of those. And for each stage, there's a standard specific set of criteria. And this is not like an hard cook rule, right? But it's more like, it's not part of the committee that's kind of prescribing, but we have a general notion, an idea on where each stage is. And as he mentioned, it can probably change on stage 2. For example, the one we have here is called array grouping, which was pitched as group array. It was group by and then group by to map. That's what it was pitched to. But as it progressed on the stage, we found that there was one particular library called Sugar.js, which uses group by, and we didn't want to kind of create a conflict with that and override with a different meaning. So we ended up renaming it to group and group to map. So things like this happen, and whenever this happens, the specification in the repo also gets kind of updated, and there's a draft, and finally, when it's published, it will have the exact specification that the committee concluded on.
Cool. And the entire process, there's like a document to describe it, and we have a repo called How We Work, which there's a lot more information that's needed, but it's a good start for trying to understand this stuff. So I encourage you to go read that if you're interested.
Yeah. Any other questions?
Yeah. Anything else before we continue? Cool.
Awesome.
So is there anything not, that can fit in the remaining time that we have that someone would like us to go through, like look through the spec text and talk about how to kind of break it down?
Yeah.
We have something in mind if nobody has any suggestions, but we're happy to take.
Yeah, and I hope someone doesn't say generators, which might take a...
Yeah, I mean, we'll probably say no if it's something very large and complex, but... I might go with regular expressions. I mean, in general, what's complex is going to depend on your own understanding, right? So, like, I personally find the grammar parsing stuff very complicated, but there's a bunch of folks that just get it, and it's fine. Also, the memory model around atomics and shared array buffers is very complicated. There's very few people who have that in their head. Yeah.
Even promises can get if you're not reading.
Yeah, and promises also, which includes async await. Like that's a pretty hairy part as well.
Yeah. So if you just open up regex, it just looks okay. It's pretty simple, just has 8 steps. But when you dive into this, like for example, what is an active function object? Then you kind of go there, read about it, and it gets complex. As complexity is subjective, but as Jordan said, some of them might get parses easily. Yeah.
Can you speak a bit more about SIMD and how that's
Sure. Yeah, so SIMD was a proposal a number of years ago. At the time, if you wanted to transpile or compile like C++ and similar things to JavaScript, you'd use something like Emscripten, and you would output called asm.js, which is essentially a subset of JavaScript with some little pragma indicator, and it tells the browser, hey, like this is compiler output, you can make some assumptions, go nuts, and it runs faster. And at the time, SIMD is like single instruction, multiple dispatch or something like that, and it's like my understanding is that it's a way to provide direct access to JavaScript developers or to the programming language developer for functions that can be executed very quickly inside the processor. And the proposal was essentially going to add a SIMD object to JavaScript with a bunch of these methods on it. And there was lots of discussion about it and lots of attempts to come up with something that would work on multiple different kinds of processor architectures. And what happens if this works on 4 of them but not the 5th, and so on. And then at some point the effort kind of faded away when WebAssembly became became a viable thing on the horizon.
Right.
And all the folks who were interested in SIMD kind of unanimously decided, you know what, let's just go with WASM. This is a better way to approach it.
Yep.
And so SIMD was made inactive as a proposal.
Yeah. And that kind of happens multiple number of times, right? If you go into the it's not kind of loading here. If you go into the proposals repo, you kind of see like stage 0, stage 1 finished, and kind of not active or not actively pursued. There might be various reasons for it, and some of them are like this, where the committee decides it can be a different entity altogether and addressed in a different way. And that question kind of explains why you have a WebAssembly sticker on your phone too. Right?
And yeah, there's a list of so we have the proposals repo on GitHub, tc39/proposals, and like that's sort of the canonical list of the committee's decisions about proposals. And there's one of the list is inactive proposals, and so some of them are withdrawn, and hopefully there's a reason there, and some of them are rejected, and some of them are replaced by another proposal, and I believe if you look up there for SIMD, there will be an explanation.
Yeah.
Possibility to which? A possibility to revive the proposals. Yes, and that has happened. Essentially, as I mentioned, you need consensus to advance things. But you also need a champion or more for a proposal. So somebody who's, at least one person who's interested in solving that problem and who has the passion and time to actually do the work required to move it through the process. There are a number of proposals. Most of the things that are kind of stalled are not marked inactive. They're just kind of sitting there in stage 1 or something, or stage 0.
Yeah.
And I mean, a number of the proposals I've advanced, I just grabbed from that pile. I was like, that looks good, and that looks good, and just started working on them. The only way I would say something's not really revivable is if the reasons that it was turned down haven't changed, right? If there's something that's just not viable for the language, then it's probably not revivable. So
and yeah, we do see SIMD here, and it goes to the notes section and gives the details on why it was kind of decided the way it is decided. And also this is kind of a natural progression for proposals, right? It's like some of the proposals, for example, group by, I feel it kind of popped out of filter by, where the proposal author was talking about why he doesn't really like the way the filter works, right? Is it filter out or filter in? What does it happen when I filter? So the argument in the room was like, how does a blue filter work? Does it filter out blue light, or does it let blue light? Or how does a coffee filter work? What does it filter? So the discussions kind of go into that depth at times, and I think from there someone suggested, if not filter, grouping makes sense, and that's where I feel the proposal came up. And there are a few many cases where the discussions where a proposal might take a deviation, or kind of we propose something but it kind of reforms into a different thing. For example, one of the proposals on stage 1, array equality, we kind of me and Jordan kind of presented it by looking for a spaceship operator that Ruby uses, similar to that, where you could compare two arrays and see if one is greater or other. Then what happens if array has objects or nested arrays and different values? How does it all work? So probably then the committee decided array equality makes more sense rather than having an operator in itself. So it kind of reforms and reshapes, and that's the beauty, right? It's all by consensus and not like one governing entity saying that this goes or this doesn't go in.
Right. And yeah, to elaborate on that, we basically had showed up, we originally were trying to solve the problem of how do you equate two arrays that might contain a bunch of stuff. And we expanded it to say, well, this is a nice holistic system with the spaceship operator and some protocol for how you compare your things. And the committee ended up kind of valuing our original problem, but not valuing the larger system that we came up with to try and fix it. And so we'll have to come back at some point with our more focused proposal.
Yep. Awesome.
Cool.
Yep.
Do you think the spec is moving towards having a more broad, like, standard library, or do you think more of these things are piecemeal as they come up? Or?
I mean, so the question was, do we think the spec is moving towards having a more broad standard library? I mean, I think that's a difficult question because I don't think there's a universal definition for what is a standard library. I mean, JavaScript has one, whether it's not cohesive in the sense that it wasn't all designed at the same time with every current use case in mind, but few standard libraries are. It's because of the requirement that we not break the web, nothing's ever going to get removed. And there's a lot of languages, I think C++ had something recently, where there's like map2 or the equivalent, right? And we don't want to do that. There was a proposal for a while for built-in modules, a way that instead of having a global, you could import something. But there's a ton of reasons why it seems to not be viable, and it's not likely to go anywhere. Globals end up being just fine. Browsers already lazy load them, so like they don't take up memory unless you're using them. So there's kind of, I think the committee is very interested in ending up with things that are holistic, that like compose and work together and kind of are somewhat cohesive. I think that it's difficult to do that because if we take the time to design something that thorough, we'll never ship anything.
Yeah.
And that's, I mean, ES6 took 4 to 6 years to be put together, and now we put out a spec every year. So we're sort of going for more of the iterative approach, but we're very cognizant throughout all the process of how is this going to affect other proposals, how does this interoperate with the other parts of the language, and so on.
And ES4 is a whole story in itself. Right?
Yeah, and ES4, the spec that never happened is a whole other thing that we won't get into.
And when you spoke about like standard libraries, I think some of the proposals are kind of hitting towards, say for example, this thing on the screen on iterator helpers, right? Which is kind of having some good set of functions rather than just having a specific thing. It's saying like, hey, let's have all of this, which makes sense for iterators. And it also says, hey, these languages already have it, and there is an npm iter tools which implements this, and there is C#, Rust, Python implementing it, which is kind of a vast proposal, right? It's not saying just go and implement a particular method. I'm not contrasting, I'm not saying that one is better than other, but just to kind of give a holistic example on the vast varieties of proposals that we have and how it progresses.
Well, and I would also add, the standard library of JavaScript includes NPM, and that's larger than every other code repository on the planet combined. So like, JavaScript is a very large standard library, and there's sort of a burden that like, we have to think about before adding something to the language. This is something we need to support forever. And it's, in order to take on the burden of supporting something forever, we have to make sure it's actually really valuable, that a lot of people are going to benefit from it, and that there is a marginal increase in value in having it built in versus having it just as a library. And some of the time that's true, and some of the time it's not. And I'm glad that the iterator helpers is advancing, and I hope it will. It's hopefully going to seek stage 3 at some point soon. But it was also right that we waited this long to add them, because now it's really clear the way people want to use iterators and what the advantages are. And even if this is the same thing we would have added a few years ago, the risk of us making a mistake is a lot smaller now. Yeah. And sort of, I hinted in this in the keynote panel this morning, like, move fast and break things turns out to not be a great way to approach anything, especially software. And so, like, I'm glad that the committee has a fast enough process that we can like ship features every year, but a slow enough and deliberate enough process that we hopefully avoid as many mistakes as we can.
Yeah. Even with that deliberations, there are cases we miss because we are humans, right? For example, may it be like just now what we show about group by, and why are we changing it so that we don't make a mistake? And may it be the ad proposal where there was like one particular website that had implemented ad, and was it the Lego website?
Yeah.
Right. So, or may it be the the flat or the flatten where the proposal author got so pissed, he said probably we should name it as Smooch Map or Smoochgate, and so people were like running out of names, and there was conflict with Dojo or other libraries using it already with the same name, and the idea is to not to break web, and Jordan has this classic example of Space Jam, right? Do you probably want to?
Yeah, the 1995 Space Jam movie website is sort of the canonical thing we say. We don't want to break that website. We were all very happy when the reboot of movie website preserved it up in the corner. There's a little link up there. But in general, it's that there's so many reasons that content on the web will fade away into history, and we don't want JavaScript to be one of those reasons. Ideally, stuff on the internet's available for as long as possible.
Yeah, awesome. Any more questions? So, do we have consensus on closing the talk? Yeah, we have 20 more minutes. Yeah. So,
do we want to jump into
from the audience perspective?
Sure. Yeah.
So we should probably pick up some other example. Maybe object.entries makes sense.
Yeah. Let's take a look at that one.
Yeah. Sure. Let me pull that up. Cool. So yeah, this looks like a pretty small method, right? Why do we even need object.entries? What was the backdrop on object.entries, right?
So this was one of my proposals, and it was one of the ones I picked up from the inactive list. Essentially, a lot of the use cases, so there was already object.keys, and a lot of the use cases that people have for iterating over objects also need access to the values. And so object.values and object.entries were both added as part of the same proposal. So essentially, this just gives you an array of entries, which is an array of key, comma, value. It's relatively straightforward. It's essentially the same as like object.keys and then mapping it to extract all the values and make the arrays.
On the console, what we're seeing here is we have an object with name Hemanth and age 0, of course. And then we have, we know that we have object.keys, of course. So if you say object.keys of object, what do we get? We get the keys, that's name and age. And when we do an object.entries of object, what do we get here? We get 2 values. Basically, those are arrays, which has those keys, the name, and that's Hemanth. And then we have age, that's 0. So how would this get implemented? Let's see in terms of the spec, right? So object is, let object be, what question mark does, to object O, which is very much similar to what we saw in map. So we are doing the same abstract operation here. We got the object. Then we are saying, let name list be enumerable object property names object and key plus value. And finally, it creates create array from that list of name list, and that's what we get. Basically, we get an array of name list. Now, probably we should go into enumerable own property names and see what it does, right? Yeah,
and real quick, if you notice the strange font there on the key plus value, that's called a Spec Enum. That's basically like, it's like our spec only strings. It's a way to kind of be very explicit about what kind of values can come in there. And we'll see that as we read through this abstract operation.
Yeah. So in the previous step, we didn't go to 2 objects. Should we just go through that and come back to enumerable? So 2 object, as we said, takes an argument. It's pretty simple. As we saw in the example where we passed undefined and null, it kind of threw a type error, right? So it basically says if it's undefined, then throw a type error. If it's null, throw a type error exception. So that's where we did a try and catch, and we caught that exception. But if it's anything apart from undefined and null, say if it's Boolean number, string, symbol, big int object, it kind of goes ahead and it uses this internal slot and gets that value, right? It's, as we said, it's like unwrapping and pulling that value out. So we did a 2 object on that. We got the object. Then we are doing enumerable own property names where we have object and key plus. So what does enumerable own property names function basically do? So we have 8 steps in this, and
there's also important information in the paragraph above where it describes the arguments. It actually tells you what kind of argument is allowed to be passed. So it's not valid to call this abstract operation unless you're passing it an object, and then one of those 3 kind values: key, value, or key plus value. And as you might imagine, those represent object.keys, object.values, and object.entries.
Yeah. So if I click on kind here, it doesn't really take me to a particular kind definition, right? It refers to the same subpoint. Why would that happen? And how do I understand what kind basically means here? Is this the same thing that is mentioned in the brackets? Is what I should imply it to be, or?
Yes, so the type of it is in the prose is mentioned in the parentheses, and clicking on it will highlight all of the other uses of that kind of variable in the abstract operation. So there's a lot of things like that. You can hover over things, you can click on things. You know, you can, if you hover over the section number,
you could do a permanent link, or
yeah, you can pin it. There's also references that'll list all the 5 places in the specification that abstract operation is called. So there's a lot of helpful affordances here to try and help you understand.
Yeah.
Yeah.
So here it also kind of gives us that brief description of what this does, right? Unlike map, where we did have a few cautions written in the green block, but here it says this is an abstract operation, and then it says what kind is, as Jordan mentioned, and then it gets into the steps where it says let own keys be again question mark o dot the internal slot property of own property keys, and it invokes and gets the own keys. So what does an internal slot mean? Like, how do I kind of map it in my mind whenever I see a double square bracket within some value?
So the double square brackets inside the spec can mean multiple things. If we're talking about a record, a spec record, like the completion record, it's a field in the record. If we're talking about a JavaScript object and it's just accessed, like for example on step 3A2, that is called an internal, or actually that's a record field, but if it's a JavaScript object and you access the double brackets on it, that's an internal slot. And so that's sort of like, it's kind of like a private field on the object. It's something that you can't really get to in JavaScript. You might have seen actually this if you console log a promise. Most of the browsers will show you the internal slot of the promise, which tells you its state and what its value is, but you can't get it that synchronously in JavaScript. It's just showing you that for debugging. So that's sort of a representation of internal slots. And the last one is internal methods, which is the case in step 1 here. These are a little confusing. Essentially, own property keys is a method that normal objects have defined, but that other kinds of objects can be defined differently. So for example, a string has its own concept of what its own property keys are. A proxy or a module namespace object, if there's a few others, have their own.
Reflect.
Yeah, and then there's also like built-in objects on the web might have their own concept of what this is. And this is sort of a spec fiction, object-oriented notation way of letting individual object types carry their own behavior with them. And so that's what it's doing here.
Got it. So as you mentioned, if I go on console log promise here, we would see these prototype and promise state and promise result and fulfill to be 1. That's like the representation of those internal slots and for that promise, right? And then we did we did own keys, and then we said let properties be a new empty list. That's the list basically that kind of gets returned at step 4 with all those properties, right? And that's the exact value that gets returns in step 3 for the method we are looking at, right? So we have let property be a new empty list. So we created that list, and if I click on list, where does it take me to? So this talks about the list and the record specification types. This is again the type within the specification. So let's get.
And these are essentially like internal objects and arrays. There's, without all the weirdnesses that JavaScript has for those things. This is just how the spec represents them.
Yeah, like then we could probably talk about records and tuples and all of those.
And that's whole different talk.
Yeah. So we have then we say for each element a key of own keys. That's the own keys that we did on step 1, 2, and then we basically are iterating through the own keys of that object, and we are saying type key is string. Says what it reads like, right? If the type key is string, then go ahead and take the descriptor of object.getOnProperty for that key. So we got the descriptor, and then if descriptor is not defined and descriptor is enumerable, basically you can enumerate through it, and that is true, then only go inside and then go ahead and get a kind which is a key and append the key to the property. else you go ahead and, so let's get into the else part, right? If the kind is key, we append the key to the property. That's like pretty simple, right?
Yeah, so that's the code path for object.keys, essentially.
Yeah. So if the kind is not key, then what is it? It's values?
Well, so based on, if you look in the paragraph at the top of the abstract operation, it tells you what the three options were, key, value, or key plus value. So if it's not key, obviously it's one of the other two.
So that's value or key plus value.
Right.
So that's where we are going to else part when saying let that value be get object value that for that particular key. And then if kind is value, then append the value to the property. The similar thing we did for key, we are now doing it for value. So if it's a key, we have covered it. If it's a value, we have covered it. So what we are left with now is key plus value. And as we mentioned previously, these are those assert statements, right? Which is saying assert kind is key plus value. And then we are saying let entry be create array from list key value. As simple as that. So it's taking that key value and creating that array. And finally, it's appending the entry to the properties and it's returning those properties. And where does that finally come into? It comes into this part where it says return create array from list, name list. So we got a name list there at step 2, then we create array from that name list and finally we return it. And that's where we have object entries.
And you'll notice there's no prefix in front of the create array from list call. It can't throw. It's just a shortcut to saying, let's take this spec list that never really exists and let's turn it into an actual JavaScript array so we can send it back to the user.
Yeah, so I've just opened up the create array from list definition. And what basically is happening here is let array be, but here it has that bang, right? That it shouldn't throw. Then it did array.create of 0. Then it said let n be 0 for each element it's taking, and then it's trying to do a create data property or throw that we saw previously. And then it's doing a toString on f bar of n, and finally it's basically iterating through all of those elements and creating it and finally returning an array for us.
Right. And even though it's all of these operations it's doing can sometimes throw in other circumstances, they can't throw here. So this particular abstract operation doesn't need to return a completion record.
Yep. That's why you just say return create array from list.
Yep.
Right. Awesome.
Yeah, and so you could look at the same at object.values, and it's the exact same 3 lines, except instead of key plus value, it passes value. So that's sort of that kind of, in the same way as making function abstractions helps make your code more reusable and less likely to be broken. The hope is that does the same for the spec.
Yeah, probably this is more of a curiosity-driven development, if you could call it so. That if you're curious about how a particular function works and you go into the spec and try to understand, then you go and get more curious on what this particular abstract operation does. You click on it and go read more about it, and that's why there are 2 ways of probably reading the spec, right? Either this way or probably some of them would like to come in more and...
Yeah, I think there's probably a lot. I mean, certainly the way that I started learning it was I already knew how map worked, and I went and read the spec and went in top down and kind of tried to understand how it worked. And then once I did that for a few functions, and once I thought I had a good idea of how the spec worked for that part of it, I picked something I didn't understand in JavaScript, and I read the spec and tried to figure out if I could intuit how it should work in JavaScript based on that. But there's, like anything, there's a lot of ways to learn something, so find out what works for you.
Yeah. So yeah, those were some of the ways that I've heard, and yeah, there might be many ways, and some of them are used to implement these specifications, right? They are probably know how the parsers work and they want to read it from that perspective. Some of them want to probably go through the algorithm conventions and read from that library.
And all the browsers and Node, right? They have different conventions around their code. So if you ever actually dig into the source code for the individual browsers, some of them are going to be really close to the spec text. Some of them are going to be entirely different. It sort of depends on how they choose to implement it.
Yeah, and should we talk more about the shims? Why were the shims came into existence, or how would shim probably map each of these specifications and when it implements, right? Yeah,
I mean, so what I've moved into is I tend to have a separate package for each thing that's a shim, and what I've done is I've built a library that I call ES-abstract, and it's most of these abstract operations, but implemented in JavaScript, so that when I actually go to make the polyfill, I just, my object.keys, or what are we looking at? My object.entries polyfill is just those 3 lines. That's all it needs. Those individual abstract operations are bigger, of course, and the actual abstract operation implementations in JavaScript are, the deeper you get, the less they map directly to the specification. But the intention is then I can, like once I have confidence that the abstract operations work, then I can implement the polyfill with them and I can know if the polyfill works correctly. And I've actually found bugs in proposals by doing this, which wasn't the entire reason I did it. I did it so I could make writing polyfills easier, but it was sort of a nice validating perk of doing it. So, and there's also a project called Engine 262 that someone is, like a former delegate has basically built to implement the entire specification in JavaScript. It's a very ambitious project. I think they've got most parts of the spec implemented. Yeah. I don't think it's anything anyone uses as their engine, but it's a really interesting kind of thought experiment type of project.
Yeah, so this is the ES abstract and this is the ES 262. Very interesting projects. And yeah, do we have any questions with object-oriented interface?
Yeah, I mean, we've got a couple more minutes for questions, so if you have anything to ask. All right, we can give you a couple more minutes back. Thanks for coming.
Awesome. And thank you for folks online too. And if you have any questions, you can reach out to us on
please do.
Any of the medium, right? And try our best to give more clarifications. Cool, thank you.